Hello world, this is JWP, J Ward Primo Beats, coming to you live from my bedroom. Check out my website, jwpsite.com, for the latest news, updates, and public offerings. If you'd like to help support what I do, check out my Patreon at JWP Patreon, that's with two P's, or my GoFundMe, gofundme.com/JWP Fund. I'll be continuing along with this series I'm doing looking at the visual VST/I programming book, continuing along with delay effects. Still in chapter 2. Basic delay effects load the input signal to a buffer and render it after a brief interval. Most employ a feedback loop, cycling the output signal back to the input. The signal repeats infinitely as the amplitude gradually decreases. Some sonic scientists insert a filter to the feedback loop to simulate a high and low dampening. Others use more delay lines, taps, to conjure complex delays. All this merits our further investigation. Devising a simple delay. SynthEdit features a module devoted to creating delay effects called Delay 2. Insert effects Delay 2. It is a delay line of variable length with built-in feedback. Figure 2.2 depicts its properties window. Delay time, seconds, sets the maximum delay time in seconds. 10 seconds is the buffer limit for delay. The modulation plug determines the actual delay time contingent on the delay time parameter. That is, if delay time is 1 second, 10 volts is the modulation yields 1 second delay. 5 volts, 500 milliseconds, and so forth. For modulated delay lines such as flanger and chorus, you should enable the interpolate output to achieve smoother transition between delay times. Again, flanger. Figure 2.2, a look at Delay 2's module properties window. So we see the module properties window has its title, signal in, modulation, and feedback, delay time in seconds, interpolate output. Oops. Just going to quickly start up SynthEdit if I can. So we're going to be looking at it. Figure 2.21 maps the simplest delay structure. Each input channel feeds the delay line, with a VCA adjusting output levels. The VCA's response curve plug is in decibel mode, so the delayed signal level adjusts on the decibel scale. The wet process signal mixes with the dry input signal to produce the composite output signal. The length slider controls the delay time, while the feedback slider adjusts feedback amount. Channels share the same settings, so this is a mono delay imposed on a stereo signal. Figure 2.21, a streamlined delay structure, delay 1.SC1. So we have an input mod, IO mod. It's going straight through, which means a dry signal, and then we have a wet signal. There are two sliders plugged into the to the feedback. Rather, it's kind of confusing. Okay, so it's just controlling a stereo signal. One's for time or modulation, the other is for feedback. And then those feed into a VCA, which apparently is running decibel mode. And then there's a level slider plugged into the volume of the VCAs. Max delay time is 1 second. To display and enter delay time in milliseconds, set the slider's high value to 1000 and divide the slider's output by 100. Or use the divide module, insert math divide, to do this. Connect the slider's output to the divide module input 1. This is the numerator. Open the divide module's property window and set the input 2 to 100. The divider slider output by 100 for an output range of 0 to 10 volts, that's suitable for the modulation plug. Add another slider with a divide module so you can control the left and right channel signal delay times independently. See figure 2.22. So in figure 2.22, we now have been introduced a right and left difference that are going through divide and then going to modulation. So there's two sliders and they look like they're set to 360 rather there. Imagine their high point is 1000. So we're going to get started on. All right, so using the previous file I had running, which was the filter 7, I just want the preset manager. So I'm just going to go ahead and delete everything else. Probably going to keep the patch manager, or patch automator rather. And these can go. Also have to reset the presets, and I can do that by deleting the preset browser. Just have to reconnect everything. Perhaps I can just containerize it. And what I'll do here is I'll get rid of this stuff, except for the out. And before I do that, I'm in fact going to stick a input output just so it holds those plugs. So if I pull all of those modules out, these plugs will disappear. And I prefer to keep them so I don't have to do any more labeling again. Okay, so that's ready. Pull all that. This is containerized. Now I can delete this. And with that goes, actually, that was wrong. I do believe it is the patch automator that stores plugin data. The preset data rather. So just gonna reconnect all that and I'm gonna uncontainerize. Best to be on the safe side, I suppose, but I do believe it is this that saves the presets. And then patch automator again. And we now have a brand new set of fresh presets. All right, so from here we have the in and the out. Perhaps I can just give this its own IO mod so it's not sort of in the way. And then move stuff down here. Just grab everything, move it up and over. Start developing here, I suppose. And in this diagram here, it shows we have a complete through. So we're going to go ahead and do that. And then we have our delay modules, of course, 2 sliders and 2 VCAs and a level slider. So delay is under effects. We want 2 and 2. Then we want a modifier VCA, and we want to set that to visible. Just put, I do believe we need 2 of these as well. So just going to go ahead and copy this. And then get some sliders happening. Right. So this one goes to modulation, and this one goes to feedback. And these go through to signal, and this one is volume. And these go directly out. And then we have directly into the delay modules here. And we'll tidy it up a bit. Additionally, we also need to do some naming. Our sliders are called time, feedback, and level. I'm just going to go ahead and line that up. Perhaps I might have wanted to keep my rectangle because I can't remember specifically what the color was. And that's under subcontrols, rectangle. And we'll just take out these rounded corners. And we'll have a look at the previous file here. Just to get those color values. And B, 0s and 7s. All right. So things are still a little plain. It's also quite large. We don't really need all this stuff. I do believe time is on top. Give it one nudge over. So we'll have to probably do 2 nudges over. To give that, it's 1 nudge. And then level, let's start grabbing these things and put them in. So we can make less space here. Oh, we still have a naming convention there. Okay. So this can come over 1. To believe we could probably squeeze these two beside each other. Just want to take advantage of as much space as we can. Okay, so those are now touching. Let's get these touching. 1 more. Bring this in. And this up. Down 1. And we'll place this over here, I suppose. Somewhere in the middle. That looks good. And we'll push this to the back. Range, move to the back. Perhaps we can drop it down a bit here. All right, so that's as small as it's going to get. Perhaps I can even just line them up in 3. However, the arrangement here and in the structure view sort of looks more like that. So I'm going to go ahead and save this. And this is still chapter 2. We'll call this delay. And I do believe this was called delay 1.IC. Okay, then we move on to the second iteration here. We have divides and we have 2 knobs, and they are measured in milliseconds. So move these over a bit here. Copy, make one copy of the time. However, it is now called right. And this is left. Then these have to go through divide. And they're each their own dedicated control. Is it divide by 100 or 10? So 10 times 100 obviously makes 1,000. I just want to double check. Just tidy things up a bit more. Let's put this one up here. And we'll drop everything kind of sort of out of the way. In fact, it doesn't look like these guys are going to operate like that. It's as clean as it's going to get. It actually looks kind of strange like that, so let's just put it back. It's a bit better. All right. So everything's all linked in now, hooked up. We can now probably move this over here and this down here. Then this guy in the middle. Lined up with this other one, I suppose. Okay. These also have to reach up to 100, right? 1,000. 100? Well, these say 360. Okay. Max delay time is 1 second. To display, enter time in milliseconds, set the slider's Y value to 1000, and divide the slider's output by 100. Okay, so I did that a little backwards here. No, that's right, 100, that's 1000. These are to be set to 1000. And I guess we'll default them at, say, 60. 600 rather. Why is this one? I'll put 10,000. Oops. Okay. We'll just copy the picture. We'll go to 360. And then feedback is 520. And we're going to save this. The output can stay at 8, I suppose. We're going to save this as delay2.sty1. Heads up. The module's property window lists every plugin default. No wires are connected to the plug. SynthEdit assumes the default value as an input, sparing you the effort of wiring up the divide module's input to plugs. The principle at work here is the same as connecting a fixed values module. Insert controls fixed value. Through this merely provides fixed voltages to the selected plugins. The values appear in the plugs label in the properties window. The prefabs use figure 2.23 fixed values. So we have a picture of a divide module having the right slider plugged into the top and fixed values at 100 plugged into the bottom. However, if we don't really need the fixed values module, it's just as we program it, it'll hold. Just saying that it'll assume that. These prefabs use a common feedback control for both channels. An independent feedback control for each channel is often more practical. The delay module in the insert to obsolete folder uses a -5 to +5 voltage range for the modulation plugin. Use delay 2 instead. Go to files, delay 1, delay 2. So there is no new version here. We're still at 2. Adding dry wet controls. You may use plugins as insert or send effects. Figure 2.24 is a schematic diagram of inserts and descends. Delay, reverb, flanger, chorus, and other effects comprising of a mix of dry and wet signals can usually serve as sends. A send effect patches only the wet signal out. The host mixes it with a dry signal, producing the output. Send effects are great for processing any number of channels without burdening the CPU. If you want to enable a plugin as a send effect, you must find a way to mute the dry signal, usually by adding dry-wet gain controls or separate gain controls for dry and wet signals. The following prefab uses separate dry and wet gain controls. So we have a picture here, figure 2.24, a schematic view of inserts and sends. We have an insert, which the effect is directly in line, or a send where an effect is in parallel with the signal. Slapping a filter on the wet signal. Delay plugins often use filters to shape the delayed signal. Types vary, though usually low-pass and high-pass filters simulate high and low-frequency dampening. The delay 3.sc1 example uses an adjacent alert 2-pole resonant low-pass state variable filter in the wet signal chain to dampen high frequencies. Insert filters SV filter. 2 VCAs adjust the dry signals. Figure 2.25, a low-pass filter in the wet chain dampens high frequencies. Delay 3.sc1. So same schematic, we now have an state variable filter inserted after the delay outputs, and then those go into VCAs, a series of VCAs, VCA dry R, VCA dry L, VCA wet R, VCA wet L. And then we have Now, two volume control knobs sort of thing that are dry and wet. We also now lose the direct line through. So to get to building that, and move those over. Of course, the VCAs also have to come over. These are wet. So I'm going to name these wet. Wet VCAR. And this is wet VCAL. Actually, I'm sure that's backwards, right? Yeah, wet VCAR. So this one's L. And then we want a dry section, or a dry version, dry selection. So I'm going to delete these dry outputs here. Then I'm going to move the signal down. And we now want another one, another signal level. And this one is dry, rather. I do additionally need to rename these modules here. So let's go ahead, call this one dry. This one dry. And then we want, it looks like the input signal comes straight out and into the dry, right? That would be dry. So let's go ahead and do that. It's the signal. And again, this signal, I can probably move everything up just to get it to sit straight. And yeah. We now additionally need to connect these here to the outputs. And we need our state variable filters. So we have a couple new knobs. We have filter cut, filter resonance. So let's get those in here. Could use the old one that has sort of the same thing going on, where it's multiple. However, I do believe this might be a bit more greedy than the state variable filter here. So we're going to use this one. It's going to be set to low pass, which it already is. And then we're going to take the signal in. From the delay, run it through to the wet. And we want a couple more new knobs here. And so we got to label these wet and dry sliders. This one is wet. And this one is dry. And then our new sliders, go to pitch. And resonance. Everything else sort of stays the same strength and mode, because we are using the low pass and there was never a strength for this original one. So filter cut, filter res. First one is filter cut. And this next one is filter res. And then we'll just get it a little cleaner here. And our default settings like 6.2 and 9. All right. I think I covered everything. Heads up, state variable means a two-pole filter with a 12 decibels octave slope. The application calculates low pass, high pass, band pass, and band reject filtering simultaneously. So you are free to choose any output signal. When resonance approaches 10 volts, the SV filter begins to self-oscillate, which is uncool in a delay filter. Confine the resonance slider range to 0 to 9 or 9.5 volts to nip this problem in the bud. So I'm going to go ahead and do that, I suppose. Filter resonance and Savvy designers set the cutoff plugs low value to about 3 volts or 110 hertz. The likelihood of lower frequencies seeing use is slim. Okay, so what was it? 3 volts? Actually, that's uncut, right? So 3 volts here. Zoom out a bit. Roughly equivalent to 22,000 hertz, 10.6439 volts is an excellent choice of high value. Anything beyond that is only the user's output here. So 10.6439. Synchronizing delay time to tempo. Users often wish, in fact, before moving on though, should this be saved? Delay 3, okay. So this is saved as delay 3. Synchronizing delay time to tempo. Users often wish to synchronize delay to song tempos. So do them a favor and afford them the opportunity to enter delay time in beats rather than milliseconds. Time to don your math cap. The BPM Clock 2 insert special BPM Clock 2 module provides the tempo in volts. Set the delay 2's module's max delay time to 10 seconds. So 1 volt of modulation means 1 second delay. 1 minute comprises 60 seconds, so divide 60 by the tempo in BPM to get the voltage required for 1 beat. Take, for instance, 120 BPM, 60 divided by 20 equals 0.5. So a beat is 500 milliseconds long. Now, what if the user wishes to synchronize delay to halves or quarters rather than whole beats? Give them the alternative by dividing the beat's length by 2, 4, and so on to arrive at 250, 125, or another increment of in milliseconds. Figure 2.26 outlines the structure for determining user length. Ooh. Excuse me. So figure 2.26, determining user length in seconds. We see, starting with a list choice that goes into a switch and fixed values that have 1, 2, 4, 8, 16, which turn into 1 beat, half, quarter, eighth, and 16th. Those are plugged into a divide. And then we have the BPM clock with the tempo out going into the bottom of a divide, fixed values going to top of that divide, then going through the first divide, coming out into length by seconds. So connect the fixed value module spare plug insert controls fixed value to the switches module spare plug insert flow control switch many to 1, thereby creating a selection option. The labels defined in the switches properties window determine which labels the list box will display. This structure resides in its own container. To show the unit list box on the container and on the GUI, open the container's property window and enable controls on parent and controls on module. If necessary, open the unit's container panel and resize the unit list box. So I'm going to go ahead and build that, I suppose. I imagine it's going to be required soon. So I do believe BPM clock is special. We have BPM clock 4. Is it the same? No, it's not. Of course, all these things are on the opposite side, right? BPM tempo. That's what we're looking for. All right. So we want BPM tempo now. And then from there, we want a set of fixed values, volts. And we want a flow control, many to 1. And we want a subcontrols list entry. No, we don't want that. We want controls list box, list entry. And then we wire 5 entries together, so fixed values to the switch made to 1 5 times. Then we're going to click the switch or fixed values and do some renaming and some value entry. So it looks like 1 2 4 8 16. As well, these have different names too. So it's 1B half all the way up to 16. So 1B half quarter 8 and 16. Then from there, we have another fixed value coming out at 60. We could probably use the same one down here. However, for organizational sake, we'll just use this one. And then that goes into 2 divides. We want 2 divides. So math, divide and divide. And our fixed values set comes to the bottom one. And this divide goes to that divide. Let's get it straightened out here. And then fixed values into the top value here, 60. And tempo out to the bottom one. And of course, list entry to control the list. All right, then from there we can containerize it, I imagine. We'll set it to a quarter, and then we'll containerize it. Some more, containerize. And then we'll hop into the container and set the output from the last divide onto the outs, and we label this pin length in seconds. So length, and then in brackets, an S. We now have it's a tempo-based delay system, well, tempo-based delay calculator. Still got to figure out where to plug it in. All right. We also have to enable controls on parent and perhaps module. We also didn't name anything, so this is unit. Rename list entry to unit. Okay, I'm not sure if I already read this, but I'm going to read it again. Connect the fixed values module spare plugin insert controls fixed value to the switches spare plugin insert flow control. Yeah, I already read that. Let's move on. Heads up, every container comes with a panel holding graphical features. You can edit and move them around as you would the main GUI's features. Tick the controls on module box to show them on the main structure container. Tick the controls on parent box to show them in the main GUI. This option serves chiefly to create custom control modules. See the section What are subcontrols from 193 onwards for details. And figure 2.27 has a picture of the measure units. What we just made there, figure 2.27 controls a module. When using the structure, be sure to set the delay 2's module's delay time parameter to 10. So 1 volt of modulation equals 1 second of delay. Once you have chosen the unit and calculated its length, you need a control feature to set delay length in the unit of measurement. In that unit of measurement, This length is always the unit length multiplied by a whole number, so you need a control feature that puts out whole voltages. Say a switch with fixed whole number values. You could also opt for a slider with an output value rounded to whole numbers, as in this example. A slider or knob produces a floating point number within the given low and high limits. Two modules round off the single voltage. Ceiling insert math ceiling rounds the input up to the nearest whole volt. 2.5 yields 3, negative 2.5 yields 2. Floor insert math floor rounds the input down to the nearest whole volt. 2.5 yields 2, negative 2.5 yields 2, negative 2. Set the slider's lower and upper inputs to 1 and 8, and the floor module will round this output signal down to the whole numbers between 1 and 8. This is fine for setting delay length in a scale based on beats. The problem is the slider's readout shows the floating point value rather than the rounded number. The solution is to use subcontrols. Switch the slider or knob's readout box off in the properties window by disabling show readout. Instead, task a text entry 2 subcontrol module, insert subcontrols text entry 2 to display the value. The inputs plug's blue background tells you this is a GUI text plugin, so you must convert the signal plug into a GUI text plug. The volts to float insert conversion volts to float module converts voltage into a float pin, which a patch memory float out insert subcontrols patch memory float out module can transform into a GUI float pin. In this case, its only purpose is to convert voltage. Then convert the GUI float value to the GUI text using the text to float insert subcontrols text to float module. Bear in mind that GUI module plug may be bidirectional. Here, the float value enters the module on the right, and the text value exits to the left. Open the text to float module properties window to specify how many digits you wish to see displayed. Set it to 0 to show only the whole number without decimals. Figure 2.28 affords you a view of this structure. So figure 2.28 showing readouts using subcontrols. So we have a picture of a slider going into a floor, which is passing to an IO and out, and then it's also passing to volts to float with that passing to a patch memory float out, and that in turn is passing back to a text to float and then into a text entry. So I'm going to go ahead and set that up, I suppose. And what initially was this? Length. So we're going to grab one of these and copy and paste, make it length. And that's it for the name. Yes. So then we're going to turn off show readout. Oh, I'm still on the other one here. What was that? That was wet. This is length. Hopefully it updates the right one. It did. Show readout turned off. Then we're going to send that to a floor. And our range for the control is 1 to 8. Let's go 1, high of 8. And then from floor, we go into an IO mod. We can't containerize that, so we'll just do that momentarily. We also want a volts to float. That is conversion. Volts to float. And I had mentioned before that it automatically convert. However, we're just going to follow the book. And that goes into a patch memory float out. So that connects here. And on the other end, we have a text to float and a text entry. So conversion, text to float, or rather float to text, and a text entry. So value, decimal, text entry, and of course this range again is 1 to 8. And we want 0 here. Expand the view a little bit here, and we can now containerize all of this. And we want our output here, which comes from here. No, it comes from floor. Okay, we'll get rid of this IO mod. We'll line this up a bit better. And we'll just put it in the corner. And then from there, we can line up the panel here. Not sure, there it is. Okay, we'll move this over. So maybe we want to put that wide, this wide. We kind of want it to match the other ones too, right? So it doesn't look different. However, it is going to be different. Let's look at that. We have a unit up here. And it looks like things aren't quite as organized as one might hope. So actually we have to turn this control on parent, control on module. And we can actually just line it up like this. So it looks like the same size, however, this isn't quite lining up properly. So panel edit, and we'll just move this over 4. 1, 2, 3, 4, and that should do it. And again, it's not going to look exactly the same, of course not. Oops. Not what I wanted to do. Let's go back to that one. Now things are kind of everywhere. This one doesn't have its outline, which is fine. Let's continue on. Now you can dump this structure into a container to create a control prefab for selecting length. Open the container's panel window and drag the text entry box under the slider. Enable the controls on parent and controls on module options for the container. Rename the slider to length. Lock the container if no further changes are necessary. For more on subject controls, refer to the section What are subsequent controls from page 193 onwards. So we see figure 2.29 is pretty much the control we just made, which is a length slider that has a single value, 3. Actually, it looks like it's smaller. So let's go ahead and shrink that. We're going to turn this up all the way just to get it to extend to 8 so we can see. I can't seem to grip it. Okay. There. No, unfortunately, it doesn't seem to be displaying anything. I do believe we have to turn on the system first. However, if I turn on the system, it might crash, and I haven't saved. I don't know when I'm supposed to save, so let's look at some of the files here. The last file we made was delay 3, so we haven't been instructed to create delay 4 yet. Heads up, embedding a structure couldn't be easier. Press the keyboard's control key or drag the mouse select to select target modules and then select the containerized selection command from the edit menu. All that remains for you to do now is select a multiply, insert math multiply module that multiplies the unit length by the slider or knob length and patch its output to the delay 2's module modulation plug. Multiplication is commutative, so the order of wires is irrelevant. Figure 2.3 diagrams the resulting structure. Figure 2.3, structure of a tempo sync delay, delay 4. So it looks like our length or our time has now been changed into length sliders. And these actually look a little bit thicker than the ones we have. I mean, as far as the visual. So, and that's tempo sync 4, right? That's delay 4. Yeah, no much of apparent changes. Why then are there things all over the place for wet and dry? Okay, so I didn't line things up last time. We'll finish this off. Actually, we'll cut these. We'll leave them in for now. Before moving on, I'm going to line things up here. Feedback, put that here, up here. Have filter cut, filter res, wet, and we'll put feedback back in the middle, however, sort of sitting on top like that. And then we're going to dry above wet. Kind of space things out a bit here. That's right in the middle though. I guess it's fine where it is. So now I'm just going to go ahead and cut these and then save as 3. Bring them back. And we're going to replace these here, 2 of these. So what happens to the divides here? Multiplies? Right, I mentioned that. Okay, so these now turn into multiply. However, I'm not 100% sure. Which value is which here? I must have to use the length somewhere. Okay, so the length goes on the bottom, on the top. I guess it doesn't really matter. The diagram shows them interchanging. That's probably what I was talking about. Let's go ahead and just put that in the middle. This one goes to the bottom. This one goes to the top. And this one to the top. This one to the bottom. And these go into the modulates. Let's tighten things up a little bit. And we'll line them up on the GUI. I do need names for them, right? Length. They're just both length. Doesn't matter which is which. I guess not. However, I am going to still line them up according to their location in the structure. And they are too tall. I'm going to shrink it down 1. Can I still shrink it down 1 without losing the 0? No. I can, however, turn snap to grid off and go 1, 2, 3. I lost it. So snap to grid back on, off, and zoom in a bit more just for control. 1, 2, 3, 4. That way we have maximum space coverage here. Get rid of that one, so I don't have to do that again. And snap the grid back on. Plug this back in here. Not sure what to do with the unit. Suppose we can put it before feedback. That also is quite large. It doesn't need to be that big. Our biggest number is 16. So we can go ahead and shrink that down some. So panel edit, and I don't see it. There it is. I'm going to move this to the top corner because that's just how I do things. And then we're going to size it just enough to give it like 1 buffer space. In fact, maybe we'll count it off. So 1, 2, 1, 2, 3, 4, 5, 6. 6 is good. And then we'll line it up. It actually disappeared, so I'm going to grab everything. In fact, I don't want to do that. I'm just going to bring in a knob. Sometimes this happens where modules disappear off screen. Retrieve them. So I'm going to go ahead and do that. Then let's maximize down that, and it should come into view. There it is. We can now just delete this straight from the panel view, and we will line this up sort of somewhere here. That's fine. Looks good. I much prefer the titles to be in line. All right. So that's done. Go to Files, Effects, Delay, Delay 4. So this is Delay 4. Go ahead and save as, and Delay 4. Serve and volley with cross delays, ping pong delays. A cross delay is much like a feedback delay, except the signal feeds back to the other delay's line input, bouncing the signal between the left and right channels, hence the term ping pong delay. Figure 2.31 is a schematic diagram of a cross delay. So we have figure 2.31. It shows a schematic where the delays feed into each other. It is an electronics type schematic, a little bit difficult to describe, so I'm not going to be doing that. We must use an internal feedback path rather than the delay 2 module's internal feedback circuit. However, if you try to create this structure with a feedback path, you will get the message, this patch contains a feedback path. Please remove. The reason for this is SynthEdit's internal structure, in which modules process audio in buffers rather than by samples. You can hurdle this obstacle using a feedback module, insert special feedback delayed to create a feedback paths. There is a minor catch though, feedback is not instantaneous. The module introduces a touch of latency. The amount hinges on buffer size, usually around 90 to 100 samples. This comes to about 2 milliseconds at 44 kilohertz. And 1 millisecond, 96 kilohertz sampling rate. Though the effect is negligible in some applications, timing may suffer in others. Heads up. Say a patch comprises 2 chains, one with, the other without feedback. Latency may elicit flanging, leaving undesirable artifacts in the signal. Insert a feedback delayed module in the other chains to compensate. On the upside, the 2 chains are now in sync, sans flanging. On the downside, you end up with about 2 milliseconds global latency. Latency compensation prevents flanging in this patch. Figure 2.32 outlines the basic cross feedback delay structure. It bases on a tempo sync patch, meaning delay length selectors are synchronized to tempo. The top 2 feedback delayed modules live in the dry signal path, delaying the signal to compensate for the feedback loop's latency. The bottom 2 feedback modules outputs connect to the delay 2 module's signal in plugs. Level 80J modules adjust their output levels, thus determining feedback level. The scaled signal feeds back into the other channel's feedback module, creating the cross delay effect. VCA modules scale the delay 2 module's output signal and determine the delayed signal level. So that was quite a mouthful and quite a to understand. I imagine there is a diagram here that would make it a little bit more easier to digest. Okay, so we have an input-output mod that's going into 4 feedback delay modules, 2 of which go to the dry and 2 of which go to the delay. So now what is happening here is I believe they're feeding into each other. Yeah, I can see the level 80J comes out and then goes back into the feedback. And then the feedback no longer controls regular feedback, it controls the level adjust. So figure 2.32 across feedback delay structure, cross delay 1.z1. Heads up, using the delay 2's module's internal feedback is a no-go. Be sure to set their feedback plugs to 0. Simply add a switch one-to-many to transform this cross delay structure into a conventional feedback delay. Choose between sending the signal to the same or the other channel to let you toggle between conventional and cross feedback. You can also add another level 80JA module that feeds back to the same channel. This lets you adjust normal and cross feedback amounts independently. This signal recycles infinitely at 100%, 10 volts feedback level. Levels above 100%, greater or less than 10 volts, continually ramp up volume, eventually distorting the signal and exploding the effect. Set the feedback to 100% or lower unless the endless loop is what you want. You can set feedback levels in decibels using a DHDB to voltage module. Go to Files, Cross Delay. Okay, so I'm not sure what it's talking about as far as setting the feedback levels in decibel. So that's probably this here. It would either be add or subtract. I don't know why we'd want to do that. So let's get to making this cross delay here. So just looking at it, where does this one go? Oops. I don't know why my computer doesn't feel like zooming right now. Okay. Why doesn't this one seem to go anywhere? Is it coming out of there and going into here? I'm going to have to look at the original schematic. Right, so I'm going to go ahead and open SynthEdit 1 somewhere. Ooh, this looks like it's loading the previous course. And we're going to go to, I think this is mine. Yeah, this is my selection. So let's go ahead and go save as, and this will give me the location here. I'm going to copy that. And then we're going to go open. We're going to pop that location into here. And we'll end up at these other ones here. So delay module, course flanger, not what I want. Delay. And then cross delay here. So where are you going? It's just going nowhere? I don't understand. What's the point of it being there if it goes nowhere? And then what's coming into dry? Strange. Well, that's the way it's set up, so I guess that's the way we're doing it. What does the panel look like? Just garbled. All right, so we include an extra module for nothing. Let's bring this up here. And we go into special and feedback, and we want feedback volts. And we want 2 of them, 4 of them rather. So we're just going to take these 2, them snapping to grid, and then we'll just copy and paste those 2 down here. Snap those in, and remember our second one goes nowhere. However, our first one does go to where? To the drive signal. Okay, so we're going to pull a plug on these. And go signal, and this one goes nowhere. And still plug it in anyway for no reason. Plug in left and right. Okay, and then those go directly to their corresponding delays. Maybe that's an oversight. I don't see why there would be a module for nothing. That's just bad practice. However, there is a signal going to the dry signal. So, okay, so audio out into signal in, audio out into signal in. Now, the level ADJs go into the opposite. Top one to bottom one, bottom one to top one. And I don't have level ADJs. So let's bring those in. So modifiers, level ADJ, 1 and 2. And our signal delay out is going into those. Do we still have a filter? No. We no longer have a filter. Okay, so no dampening. And that also means the filter. These go, however, they will be useful for something else later. So these go in here, level ADJ, right? Okay, and it also goes to dry. So that's the concept. I still don't understand why. Does it go past level ADJ? No, it goes directly out from delay into our second dry here. Okay, and then level ADJ1 goes in rather to our first one. Oh, second one here. Let's get this more in line with that one because it's kind of confusing me a bit here. So move this over, move this around, move this up, move this down, move this over there just to get it out of the way. It's not part really of the schematic. All right. Still, we're at a bit of a loss here. Our multiplies look like they are lower. So we'll drop these down here. Grab all these controls, bring them down here. And then these feedback guys, this stuff comes forward, unfortunately. And then this stuff comes down. It's a little more comprehensive now. I wouldn't say comprehensive, but a little more mirroring. Okay, so level ADJ coming from feedback. Let's get these changed. This is feedback. And the other one is wet. So we don't need a secondary. We just want feedback. And that gets connected to the bottoms of those. And our bottom one goes to the top one, right? And our top one goes to the bottom one. Also, feedback is in both. So our bottom one goes to the top one, and the top one goes to the bottom. Okay. And then the feedback delayed goes to the wets. In order? No. This one, feedback delay, seems to be sort of its own deal, like this. And then this one comes from the delay. Like this. And of course, they all go to the output. And wet and dry. Okay, so I'm sure I've wired it in okay. Everything looks really scraggly though. I feel like this can come up and over here. This can come up over here. Just kind of squeeze it in there. And everything can come over here. Okay. One more time, just looking at it again. Right, where's this going? So that's going to the bottom one. And this one's going to the top one. So neither of these level adjusters go to the output. This one goes to the bottom one, this one goes to the top one. And then the outputs come from here, direct to the module, And like so. I'm just having a hard time comprehending why things are the way they are. And I just connected itself to itself, which is interesting. Usually you're not allowed to do that. Okay, so the top one goes out and the bottom one comes from delay. Yeah. No. What? So that's wrong. The bottom one doesn't go out. The bottom one comes from delay. So let's pull this and the delay here. Okay, and this one's out. Yeah. Wow. All right. I feel confident that it's right. Let's see what the panel looks like. Okay, so we didn't really lose anything. It looks like we lost like, we have 2 feedbacks now. Okay, so this is no longer usable. These have to be 0, which they are. That's probably what was throwing off the way it looks here, is that there was that space there. So could probably tighten things up, but it's fine the way it is. And I feel confident that's right. So we call this cross delay 1. Save as, oops, not that one. This one. Actually, let's look at the panel first, right? And we'll just move feedback to the middle here. Same with the unit. 1, 2, 3, 4, just to get it centered. Okay, now we can save this one as cross delay 1. Is it caps? No caps. So cross delay 1. All right. Looks like we are moving on here. Lining the feedback path with filters. In the patches we have worked with so far, the Delay 2's module's limitations prevented us from inserting filters in every feedback loop. Instead, we filtered the global wet output signal, but adding filters to the feedback path puts far more sound shaping power at users' fingertips. It enables realistic simulations of dampening, where the effect accumulates with every feedback loop. Resonance and gain pile up quickly in resonant EQ and shelving filters with positive gain, soon blowing the effect up. To prevent this, use filters without resonance or with gain normalization, DH multifilter 2, or allow negative gain in shelving filters only. The following example employs cascaded one-pole low-pass and high-pass filters with a smooth 6 decibel octave slope for high and low frequency dampening. Place filters pre-delay to effect so the filtering effect accumulates. Figure 2.33 illustrates the structure with the filter. All right, figure 2.33, a cross delay with filters lining the feedback path. So it wasn't confusing enough. Now we're going to really get into it here. So I believe it's sort of the same thing, but it's just intercepting before the delay, which is still kind of confusing because that whole line is confusing. So these are the one pole filters. Let's get them in at least. One low pass, one high pass. And it almost feels like we have space here for them. However, that's not the case. If we were to line up something similar to the other schematic, would be something like this. And I'm just going to grab this, and we're going to move to sort of a more neutral space where we have more room to work here. And move these up a little bit because I want to visualize things a bit better. And then we'll bring in the filters. So high, high, low, low. These are just the standard filters. 6 decibel slope. All right, so following the schematic here, we now have 2 more controls. Let's get those in. This is high frequency dampening and low frequency dampening. Rather, which order are they in? Low pass, then high pass. High frequency, then low frequency. So LF damp and HF damp. And those go to pitch. Right. Now I got to figure out the signal. It'd be wise to just open the schematic and wiggle it around opposed to there's no cross signal, no cross delay 2. Oh, what is it called then? Jumping ahead a little bit. Yeah, it's called cross delay 2. I don't know where it is. Okay, that's that folder again. It keeps defaulting me there. Oops. Okay, cross delay 2. No change, save changes. So we're going to start spreading things out a bit here. So it appears to just directly intercept. I'm not sure where the feedback path happens then. Level adjust. Okay, so there's a level adjust, right? And then delay, and then the output should come from one of these. But in fact, it doesn't. So why does it now come from the delay? Okay, so it's not exactly the same. We now have like what was expected, really. So our dry goes straight through. Yeah, cross delay 2. So signal, and then we don't want this coming through anymore. We also want to pull the plug on this. Okay. And we'll pull a plug on these. These go straight through now. So, oops. Like so. Yeah, let's move these over so we can kind of see what we're looking at here. Then we'll move them into place. Sort of move these controls out of the way still. Again. And then, is it just left and right here? Straight through. Left and left. Right and right, yeah. So straight through. Looks like we got to move everything up here. It's kind of getting a little lopsided. The whole schematic's constantly shifting and moving. It's interesting. Okay, and then where does our feedback come in? Looks like it's already done, right? Our feedback comes from the delays, from the level adjusts, and they go across. And then the output goes straight out. So a little more simpler. Nothing too confusing. So you delay out, that's already done. That one going through. These are crossing over. Feedback's controlling them. They're feeding through again. So forth and so on. So now let's fix up the panel here. Right, so let's pull this in. And again, we're going to have to move this over 1, 2, 3, 4. And we'll go, looks like low frequency dampening is first, then high frequency dampening. And I feel like things are off a bit. It's a bit better. I don't think that worked properly. So we're just going to snap things around here and go 1, 2, 3, 4. There. I really want to move this down now. Keep it in line. And that is cross delay 2. Save as cross delay 2. All right. To the book here. Heads up, filters in the feedback path are nifty, but many settings cut the signal's amplitude. Feel free to use feedback levels a touch over 100% for experimental effects. This lets you create endless ambient textures, but mandates careful adjustment for the feedback level. A peak limiter comes in handy for limiting high feedback levels. Drop pan modules in front of the amplifiers to stereo pan the two channels and create leaner effects. Place any filter or effect in the feedback chain, say flangers and phasers, to conjure striking soundscapes. Again, proceed with caution when using level boosting prefabs and adding resonance or feedback, as output levels may soon spike. So a lot of that's talking about more experimental things, especially a touch over 100%. So it's talking about pushing the level ADJs beyond 10, I believe. Caution. Before experimenting with structures containing external feedback paths and potentially high feedback levels, back off speakers and headphones volume to protect your equipment and hearing. Go to Files, Delay, Cross Delay 2. Doing the multi-tap dance with delays. Many delays feature several delay lines called taps for greater flexibility. Adding delay 2 modules does this trick neatly. Things keeps reasonably simple. This example converts the incoming signal to mono, adding the 2 channels and multiplying by 0.5 to get the average. This composite signal feeds into 4 delay lines. A low-pass filter follows each delay to dampen high frequencies. A dedicated pan module pans mono signals in certain modifiers. Pan and a value range of -5 to +5 volts determines panning positions. Like a level adjuster module, the volume plugs adjust levels. Just going to take a peek at how much is left here. Okay, so this is the last delay. Might as well finish it off. A third-party conversion module called DHDB to voltage adjusts levels in decibel increments. Built by David Happ, it comes with his basic module pack. DHDB to voltage converts precise decibel values to voltage for use with linear level adjustment modules. For example, level adjust or pan module's volume plug. With the VREF plug set to the default 10 volts, the value is in standard 0 to 10 scale. The default range of decibel in plug is -100 to 0. So if you connect a slider or knob to it, its low and high values adapt automatically. A decibel range of -40 to 0 will do for a tap volume. All right, so it looks like we have to do some conversion here to do these taps. We'll look at that momentarily. Now adjust the dry signals level and mix it with the 4 taps output signals. The delay lines delay the time. The delay line's delay time is 1 second default, so the slider's high value is 1. Divide each of the slider's output by 100 to enable millisecond delay for length settings. All taps sport a dedicated feedback control. Figure 2.35 shows 1 tap structure with the dry signal. So, figure 2.35 here. Structure of a 1 tap with the dry signal. We see the output going into decibel to voltage here, into a level adjust. I'm not sure why it's going into VREF. It looks like it's going, okay, it's going right through, and there's a level adjust, right? dB in, that's coming in from there. Now, we have multiply here, and it's combining them and averaging them out to a delay 2. And we have a time coming through divide. It's likely divide by 100, right, for 1,000 milliseconds. That's going into modulation. The signal out is going into a state variable filter, and that has its cut, filter resonance. Then we have a pan, which is giving us a, where's our pan? There's our pan knob. level decibel output, that's going to the volume for pan. And then that goes to the outputs. Okay, so it looks like we have a dry signal coming into these level adjusts, and that's being adjusted, and then the pan is being the one controlling the wet signal. So level decibel. So again, with the dB to voltage conversion, it is not native in SynthEdit, and I'm avoiding use of third-party modules. So we're just going to go ahead and ignore this and turn it into just standard level volume. There'll be no decibel increments or decrements. Either way, it would kind of be the same. This isn't like a gain structure, so it would only be negative 100 to 0, right? So 0 to 10 is fine. Drop the tap into a container to tidy it up. Hold the control key to mark the divide delay to SV filter pan and decibel to volt modules for the tap. Then select container as selection from the edit menu. Change the new container's input labels. The decibel to voltage and level adjust modules for the dry signal are also containerized for your convenience. Figure 2.36 maps this structure. All right, so what happens is it gets built up here, and that's one tap. So we're going to go ahead and do that one build here. Looks like we're done with this schematic here. So that's saved. I'm going to go ahead and double save that. And what kind of controls do we still want left over? We want time, milliseconds, filter, cut, filter. We don't think we have any of those. We don't have level. So we don't have any of these controls. It's not tempo based. So all we really want to keep is just a certain amount of controls to cover the bases of 1, 2, 3, 4, 5, 6 controls. So we have 5. We just need one more. We'll just do the renaming as we go. So we're going to nullify all this. And what I'm going to do is I'm going to save this right away so I don't accidentally save over it. And this is called multi-tap 1. Multi-tap 1.sc1. Okay, so now we're going to start building this here. So we'll start by with the multiply in the level 80Js. Work our way to the middle. The multiply and 2 level 80Js. So we can start probably tidying things up a bit. And then working our way in, we have divide delay, pan, and SV filter. So math divide, effects, delay, filters, SV filter again. And what was the other one? Pan. I do believe that's a modifier. Okay. And as I said, I'm not going to be doing any decibel to voltage conversion. So we just have to wire everything in here. Not too difficult. I got to figure out what these values are, though, however. So I'm going to go ahead and reopen. Again, we are in a funny place. Let's get back to where we want to be. Delay and multi-tap 2. No, save changes. So we're just going to head in here. Actually, let's go to multi-tap 1. So we have an exact reference. Okay. So in the multiply, our value is 100, right? 0.5, right? It's averaging the signal. So we just plug both of these in, and then we average it by dividing it by 2 or multiplying 0.5. Oops. And then that goes to the delay in. Rather, we have a dry, say bump into the level EDJs as well. And this goes into the delay. Why do we have a divide? Okay, that comes from the time for the modulation. That comes in turn from time milliseconds. So time milliseconds. Oops. And what's on the other end of this divide? 100? Yeah. That makes milliseconds. So we'll go ahead and divide that by 100. And this goes up to 1,000. And what does the default look like there? What does it say? 360? I'm not sure why it's always 360. It's more of a degree thing. Feedback, we have a control for feedback. I think I just changed to when that was already named feedback. That goes into feedback. And from there, it goes into the state variable with using the low pass, which is usually by default already. And pitch and resonance. So what is this? Filter cut, filter res? Yes. Filter cut and filter res. All right, then from there, that goes into the pan. We have a pan knob and a volume control. It looks like we're missing a knob because we still need a volume control for the other one, right? So this is pan, pan. And this is volume. What's called level. And we're still missing a level, or dry. So I'm going to go ahead and copy level, paste that, we'll call that dry. And then so the pan, the dry goes to where? Well, it goes here, and then these go to the level adjust. Yes. These come out. Where is this going? Directly? Directly out, yeah. So left and right, and left and right. And that's a single tap. So I'm going to go ahead and line that up on the structure. Pan, let's go time and feedback. Pan can come towards the end here. Filter resonance and filter cut can be on top. Pan here. And level here and dry up here. Just to sort of reflect the schematic a bit. Looks like we got quite a bit of space going on here. Let's mimic that space. Do we want to mimic that space? Pan can come down the middle here. Yeah, that's fine. Sure. What's the defaults for the numbers? 715472. And feedback 5.95. Dry, well, those are 0 dry, so that'd be full blast. And then this one is take 8, so dry full. Okay. So that is multi-tap 1. Yeah, because I already saved it, so I wouldn't accidentally save over it. All right, now we move on to multi-tap 2. To add more taps, simply copy the tap container with its controls, connect the average input to this tap signal in plugin, and connect its outputs to the I/O module. Figure 2.37 shows the entire structure. So this is multi-tap 2. What I'm going to do is I'm going to copy it up here. So apparently one module is just this. Containerize that. Do we have to do any naming here? Yes, not really, no. We can call it dry input or dry. And then everything else as well gets containerized except for the controls and the multiply. It looks awful. Anything we need to do any naming for? So we have time. It's now going to be here. And signal in, that's right. Feedback is there. Pitch, resonance, pan, volume. It just looks awful. That's all there is about it. And I guess we can line these up how it's kind of neatly stacked in the thing here. Level, pan, filter cuts. So level, pan, filter cuts. Filter rest time feedback. And it looks a little bit better. All right. So this is containerized tap and level adjust modules, multi-tap 2. Save as multi-tap 2. And we're going to move on. What happened there? Getting a full page here. I think we went up, down. Yeah, I just moved around. Okay, Figner 2.37, a delay structure with 4 taps, multi-tap 3. So if we look at it, it is quite humongous looking. And our dry is kind of independent, and then our multiply, that's why it stayed like that. Now our pan is also a horizontal slider. So let's go ahead and make that horizontal. And we're going to save this right now as multi-tap 3 so I don't accidentally save over it. And then we want to emulate this. So we got 1, 2, 3, 4. And yeah, perhaps it might even just be easier to containerize everything here and just copy and paste it 4 times and wire things like so. Okay, so more uncontainerized. It's over. Just check the panel for that. Looks like everything's okay. Again, we're going to have to, maybe we can tighten things up. Do we want to tighten things up? I suppose so. So let's move things over 1. These ones can come over 1, and that can come over 1. It's a bit tighter, and then we can make space for the new ones coming in here. Let's go by 4. Move this down, and we'll start sort of unwrapping or uncontainerizing these ones. So here's 2. Imagination. It's not definitively 2. It's just feels like 2. And it looks like we're missing control. It looks like we missed a dry. Dry is its own control. That's right, too. Okay. What does that look like here? It's not even called dry. It's just called called dry before though? Yeah, it was called dry before. And here too. Okay, so now it's called double. So dry. Well, what are these called then? Wet? Oh, they're called double too. That's confusing. So I'm gonna keep that as dry. Actually, I should follow the book to the letter. So where's our level? Dry. Let's just move it out of the way for now. And then we can perhaps move this up. I know there's going to be a final image that's going to determine what this looks like. I have to do this a few times. Okay, then we can tighten things up again. It's going to give, like I said, it's probably going to give us a final image of a structure view, probably with structure panels and everything. So uncontainerize again. I just want to keep things neat here. So I can understand where things are. So this would be what, 3 then? Down here. Just line things up again, even though we're probably wasting time doing that. Over. And 4. Then again, it might not give us a final image, so this will be multi-tab 3, 3, 3. And up, in, and over. And I do believe this can just kind of sit. Let's like make a space in the middle just to differentiate them. So we're gonna go over, again, over, then everything down. That's too much. We'll just stick this in the middle like this. Then we'll bring things in here. And again, expanding the bar here. Not sure what the original would have looked like. This can sit back behind everything. Then, of course, there's the naming. We'll stick that in the middle. Sure. Okay. And everything is completely wired in now. That is multi-tap 3. Yeah. Go ahead and save that. All right. Go to the files, multi-tab 1, 2, 3. Finalizing the multi-tap delay. The effect is nearing completion. Only the GUI awaits your attention. Open the panel window and behold Jumble Mess at its center. Panels housing so many controls features call for some tidying tricks. Grab a control feature and drag it away from the rest. Leave it selected and go to the structure window where it is also selected. Select all control features in that group by holding the control key and dragging the mouse. Now you can move them collectively on the panel window by dragging the isolated feature. This method also works useful for identifying which controls feature are in the selected panel. Here's another approach. First, lay out one tap's control features in the panel window, then copy and paste the structure window. Select the tap container to do this. Copying also clones control features, panel positions, you move them correctly. So pretty much figure out how you want to do it. What it's talking about is, for example, this one's probably all cluttered, right? So it's talking about grabbing. Actually, I'm going to use the, again, we're here. I'm going to use the exact example. Heading out, delay, multi-tap 3. So everything is going to be cluttered, right? I think. No, it's all laid out nicely. Of course it is. Let's go back to this one. No, let's go back to 2. So I believe what it's talking about is just selecting a group like so, and then sort of moving them out of the, so you only have the dry left. And then you can go from there and start organizing. You know that that's for that section. Sort of what I did. All right. So this is a possible layout for for the 4-tap delay using the default skin. So it says tap 1, 2, 3, 4, and then dry. And each of them all contain the controls. They're all lined at the bottom as far as the readouts are. And then dry is sort of on its own. I guess that's why it has the same name level. And as we just seen, the alternate to that was the multi-tap delay 3. And it sends the taps out individually, and then each tap sort of has its own dedicated area. So that's more vertical. And I imagine multi-tap 3B would be the horizontal that's demonstrated in the book. Yeah. So I'm not really sure which is better. Usually a lot of audio racks come horizontal. There's more space on a computer screen horizontally. In the majority of cases, my example, however nice, looks okay. It just doesn't have those structure groups. So let's go ahead and follow the horizontal example here. So we want 5 structure groups. We're going to go into controls and we want structure groups. Let's switch structure group. Panel group, they're called, rather. Sorry. My bad. Panel group 1, 2, 3, 4, and output, dry output. So we'll line up like so. How does it look here? Okay, why is 3 over there? We go like Japanese style, 1, 2, 3, 4, like Oriental style. Whereas like Western style is like from left to right, and then down and left. It doesn't really matter because they're not really in an order, right? So to sort of just, there's no real way to differentiate them. You tap. They're just labeled 1, 2, 3, 4. Like I said, there's no actual consecutive order. How do I want to do this then? So we could just call them all tap, save time. Tap, 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 tap. And there's no way to say like tap ABC or 1, 2, 3. That all, every measure is consecutive, really. We'll just go a Western style. Tap 1. So we're going left, right to left. Tap 2. I don't know why they decided that. Up to down. Tap 3. Tap 4. Again, it is in English too. So the final group is called dry. And then we want to change this to level. Properly punctuated. And we can start moving things around here. So I'm just going to grab everything, just chuck it out of the way. We'll start with tab 1 here, and we'll just migrate things in as we go. So what does that look like here? They're pretty much touching, eh? It's kind of weird. Let's get some space here. We'll jump to the middle. It's likely not going to be enough space. In order, we have time, feedback, feed B, LP cut, LP rest, pan level. So feed B, time, no milliseconds. Is it milliseconds here? Yeah, it is. So time. It's about the same amount of space. It looks really crowded. I'm going to give it a little bit of space here. Maybe it's just not snapped vertically. Appears to be. So, well, it's right at the edge, which is fine. Time, feed B, LP cut. Just gonna make some more room here. LP rest. The names are likely shortened to make things fit here. Pan, which sits on the bottom. Looks off a little bit. Go 1, 2. Click this here. 1, just 1, 2, 2. It's not the same size. I don't think it is, eh? No, it's the same size. Okay. So let's get it in its awkward position again and go 1 up. Look wrong. I think it's just the way it sits. It messes with the eyes. Level next up, which is called level. Okay, and that completes that. Let's tighten it up. And then expand it some more. Let's get this background out of the way. Bring in tab 2. That's 4. Let's put that here. Tab 3 over there. Tab 2. So again, to save time, all that relabeling, I can just containerize this with this. Let's get rid of all this except for dry. And then I can just containerize this. Containerize, and then copy that 4 times. And then just connect it up. Then as I unwrap, I don't have much aligning to do. So let's first unwrap this. Containerize is the proper term. Let's go to panel edit. It unwrap or uncontainerized itself in the sort of right place, I suppose. And then we'll go to the next one here. Yeah. Why do I only have 3? Didn't I make 4? It did. It's just hiding back there. Okay. Now let's get other things connected up first. Okay. So let's uncontainerize this. Just kind of squeeze it in here. Everything's selected. We'll just move it over. And of course, in the book, they touch. So because I can keep them touching. And then tab 2. And tab 3. In the book, they don't touch. Rather, the examples don't touch. It's quite close, though. But this doesn't allow it to be that close. So that's fine. Just tab 3. And finally, tab 4. And of course, dry, which sits off to the side. And again, it's completely touching everything. Down. And stick this in and center it out. I believe both there, center. Feels a little wide. Maybe you can pull it in a bit. No, it's actually symmetrical. And the other one, I don't know why this one doesn't want to be symmetrical. Oh well. 1, 2, 3, 4. That's still too much. Okay, so 1, 2. There. And it's really tight, right? And again, from the bottom, really tight. We're going to expand the preset manager. Pull this forward. I wonder if we ended up with any presets. No, there's no preset manager, so just what's here. A little disappointing, however, that's fine. Stretch this over here, bring this up. And there it is. This is multi-tab 3B. And that's it for this video. So apparently next time is reverb. Again, the prefabs will be available on my Patreon, JWP Patreon. Check me out on YouTube, or rather, check out my website, JWP site, to stay up to date on news, events, my latest public offerings. I'm not sure will ever be in events. I guess they're streaming events. And if you want to support what I'm doing, check out my Patreon, JWP Patreon, or my GoFundMe, gofundme.com/JWP Fund. Thanks for watching. Until next time.